For 100 million miles from where you're sitting, there's an ocean that was never supposed to touch the surface. Not a drop, not a stain, not a single molecule was supposed to make it through. And yet, buried in data from the most powerful telescope ever built, scientists just confirmed something that shouldn't be possible. Chemistry, from inside a hidden alien ocean, sitting out in the open on the surface of a moon. Nobody was watching closely enough. And that is not a setup for anything else. This is the actual finding. Welcome to a story that nobody saw coming. To understand how strange that really is, you have to go back to the very first time anyone noticed this moon at all. January 1610. An Italian astronomer named Galileo Galilei pointed a homemade telescope at Jupiter and noticed 4 small points of light lined up beside it, moving with the planet. They were orbiting. He had just found the first moons ever discovered around a planet other than Earth, and one of the 4, the smallest and faintest, the second one out, he logged and moved on. Later generations would name it Europa. For more than 3 centuries, that was basically all anyone ever said about it. Europa sat in telescopes as a dim smudge of reflected light, smaller than our own moon, wrapped in what looked like plain water ice. No atmosphere, no visible activity. Nothing that hinted it deserved a closer look than any of the dozens of other frozen moons scattered across the outer solar system. Just background scenery. Then 2 spacecraft showed up, and the picture stopped being simple. In 1979, the Voyager probes swept through the Jupiter system on their way further out into the solar system. Their cameras caught something researchers did not expect. Europa's surface was covered edge to edge in long, dark cracks, curving and crisscrossing like a cracked eggshell. But there were almost no craters. On a body that old, sitting in a solar system full of debris constantly slamming into everything. An almost crater-free surface only means one thing. Something keeps resurfacing it. Something keeps erasing the damage. Voyager could not explain what. It photographed the puzzle and kept moving. It took more than 15 years for anyone to get close enough to take the next pass. In 1995, NASA's Galileo spacecraft arrived at Jupiter and spent the next 8 years orbiting the system. Its magnetometer, an instrument designed to read magnetic fields, not take pictures, picked up a strange, shifting signal every time it flew past Europa. The signal behaved exactly the way it would if a layer of electrically conductive liquid was moving beneath the ice shell. Salt water conducts electricity. Solid ice mostly does not. The simplest explanation was also the most extraordinary one. Somewhere under all that ice, Europa was almost certainly hiding a global ocean of liquid salt water. Voyager didn't find the answer, it found the question. Galileo didn't find a picture, it found the ocean. And for nearly 30 years after that, everyone, genuinely everyone, agreed on the same working theory. Whatever was down there was staying down there. The ice shell was thought to be miles thick in most places, hard as rock at those temperatures, more than solid. Enough to keep an entire ocean permanently cut off from the surface above it. Ocean chemistry, scientists agreed, could exist. It just could not reach us. Not through that much ice. Not without some kind of direct opening. A crevice, a vent, something spacecraft had never actually confirmed. Sealed. That was still the assumption when the James Webb Space Telescope turned its instruments toward Europa. Nobody expected that assumption to survive very long. Here is what makes Webb fundamentally different from every spacecraft that visited Europa before it. Voyager and Galileo could only see shapes, cracks, colors, rough textures on a distant ball of ice. Neither one could tell you what any of it was actually made of. Webb does not need to fly past anything to answer that question. It reads light itself, splitting it apart into individual wavelengths to reveal the precise chemical fingerprint of whatever it happens to be staring at, hundreds of millions of miles away, without ever leaving orbit around our own planet. The challenge here was never really about whether Webb could detect chemistry on Europa's surface. Webb can read the chemistry of almost anything that isn't moving too fast. The actual challenge was harder than that. Researchers had to prove the chemistry came from inside Europa itself, and not from the constant rain of comets and meteorites that falls onto every icy moon in the outer solar system. If carbon was evenly scattered across the surface, no one could tell you where it actually came from. To say the ocean was reaching the surface, they needed to find the chemistry clustered in one specific place. And they needed an isotope signature no other source could explain. In September 2023, two independent research teams answered that question from opposite ends of the United States. One team, led by planetary scientist Samantha Trumbo at Cornell University, mapped the distribution of carbon dioxide ice across Europa's entire surface. What they found was not carbon dioxide scattered randomly everywhere, the way you would expect if it were simply falling in from space. It was concentrated almost entirely inside a single region called Tara Regio, an area of chaos terrain, young, jumbled, recently disrupted ice that spans roughly 1,800 kilometers across. More than 1,000 miles of surface that looks less like a frozen shell and more like something that has been actively churned from below. A second team, led by NASA Goddard scientist Geronimo Villanueva, reached the same region independently and confirmed the same pattern, while going a step further. They measured the ratio of two different carbon isotopes locked inside the ice, a kind of chemical signature that behaves differently depending on where the carbon originally came from. The results pointed the same direction both studies did. This carbon dioxide almost certainly did not arrive from outer space. It formed inside Europa, most likely within the ocean itself, and was carried up through miles of solid ice to sit exposed on the surface in a spot scientists could actually point a telescope at and study. That is the part that shouldn't have been possible under the old assumption. An ocean sealed away by miles of ice was supposed to stay sealed. Instead, in at least one region of this moon, ocean chemistry had apparently found a way through, geologically recently, and settled somewhere researchers could finally read it directly, without ever touching the ice, without drilling a single hole. If a discovery like that surprises you as much as it surprised the researchers who found it, drop a like on this video. Genuinely. But the story does not end as cleanly as that headline makes it sound. And this is the part most coverage of the discovery left out entirely. Villanueva's team was not only searching for carbon dioxide, they were also searching for plumes, active jets of water vapor erupting directly out of cracks in Europa's ice. The same kind of feature already confirmed on other icy moons like Enceladus. If Europa's ocean really was connecting to the surface, plumes seemed like the next logical thing to find. And there was reason to expect them. The Hubble Space Telescope had picked up tentative hints of exactly this kind of activity back in 2014 and again in 2016, faint signals that some researchers interpreted as possible eruptions near Europa's southern hemisphere, though a later reanalysis in 2019 walked back some of that confidence. Webb looked for that same activity with far more sensitive instruments than Hubble ever had. It did not find a single plume. No jets. No active eruptions. Nothing breaching the surface during the entire observation window. That does not necessarily mean the earlier Hubble signals were wrong, or that plumes never happen at all. It may simply mean they are rare, unpredictable, or active only in brief windows Webb happened not to be watching during. But it does mean the picture is more complicated than a straightforward story would suggest. Europa's ocean appears to be reaching the surface through slow geological upwelling in specific regions like Tara Regio, not through the kind of dramatic visible eruptions many people expected once the CO2 result came out. Picture for a moment what it would actually be like to stand where that carbon dioxide was found, because it is nothing like standing on Pluto or any other place you might imagine. Jupiter would not be some distant point of light in Europa's sky. It would dominate it. An enormous banded sphere stretched across more space overhead than anything in Earth's sky ever gets close to. Close enough that its clouds and storms would be visible in detail without any equipment at all. But you would not want to linger looking up at it, because Jupiter's magnetic field traps and accelerates radiation into some of the most intense belts anywhere in the solar system, and Europa sits directly inside them. An unprotected astronaut standing on that ice for even a single day would absorb a radiation dose far beyond anything survivable. It is one of the most hostile patches of real estate in the entire solar system, sitting directly on top of what might be one of the most promising oceans in it. The ground itself would look almost artificial. Long, reddish-brown cracks stretch across a surface so smooth in places it looks polished, broken up by exactly the kind of jumbled, refrozen terrain researchers found the carbon dioxide inside. Chaos terrain earned its name honestly. Blocks of ice tilted, rotated, and refrozen in place, looking less like a frozen ocean and more like a shattered window pieced back together in the dark. And underneath every one of those cracks? Potentially, an ocean scientists believe holds roughly twice as much liquid water as every ocean on Earth combined. And here's the part nobody in the headlines ever quite lands on. An astronaut standing on this ice wouldn't need to drill. For the first time in 30 years of arguing about Europa, there is a real possibility that the ocean brought itself up, and we just had to learn how to read what it left behind. Every serious conversation about life beyond Earth eventually runs into the same practical obstacle. You cannot search chemistry you cannot reach. Drilling through miles of ice on a moon 400 million miles away is not a realistic option for any spacecraft humanity has built or is currently building. What the Tara Regio discovery suggests is that Europa may not require that kind of drilling everywhere. If ocean material is already being carried up to the surface in specific regions on its own, a spacecraft could sample ocean chemistry simply by studying the right patch of ice, without ever touching what lies beneath it. It is worth being honest about the limits of what has actually been confirmed here, because overselling this discovery would defeat the point of covering it carefully. Both research teams were careful to note that detecting carbon dioxide with an internal origin does not tell scientists whether that carbon came from ordinary geochemistry or something more biologically interesting. The isotope ratios measured so far cannot distinguish between those two possibilities. What has been confirmed is narrower and still remarkable. The ocean and the surface are not as separated as the old model assumed. And there is now a real bridge between the interior chemistry scientists have wanted to study for 30 years, in a location an actual instrument can point at. To be honest about how this compares to where the field already is, Saturn's moon Enceladus has gotten there first. Cassini spent years flying through the plumes erupting directly out of that moon's south pole. In 2023, those reams of data finally revealed phosphorus, a literal building block of DNA, mixed into the material the plumes were throwing off into space. Enceladus has active, confirmed geysers, and now confirmed phosphorus. Europa doesn't match that level of evidence yet. But Tara Regio is the first crack in the wall between Europa's surface and whatever is happening in that ocean. And once an ocean finds a crack in an ice shell that was supposed to be sealed, the question is no longer whether the chemistry can reach us. The question is, how much of it? Here is where this story gets to end on something most outer solar system discoveries do not get. An active, funded, already flying answer. NASA's Europa Clipper spacecraft launched on October 14, 2024. It is not sitting on a drawing board waiting for a budget decision. It is already in space, already moving. On March 1, 2025, it swung past Mars for a gravity assist, passing just 550 miles above the planet's surface. On December 3, 2026, it will swing back past Earth for a second gravity assist, using our own planet's gravity to pick up the final push it needs for the long journey outward. By April 2030, Europa Clipper is expected to enter orbit around Jupiter and begin the mission it was actually built for. 49 close flybys of Europa, some dipping as low as 16 miles above the surface, systematically mapping the moon's ice shell, its composition, and its geology in more detail than any spacecraft ever has. Tara Regio, the exact chaos terrain where Webb found that ocean-sourced carbon, sits directly inside the kind of terrain Clipper's instruments were designed to fly over. Everything covered in this video is not the end of a story with no way to follow up on it. It is the setup for a mission already more than halfway through its journey, with a specific, real date attached to when we get the next real answer. Step back far enough, and Europa stops looking like an isolated mystery and starts looking like part of a much bigger pattern. Enceladus already has confirmed geysers. Titan, Saturn's largest moon, hides its own subsurface ocean beneath a thick, hazy atmosphere, and NASA's Dragonfly rotorcraft is being built to land there directly, targeting a 2028 launch. Even Pluto, long since written off as a frozen leftover, has its own quiet case for a buried ocean, built on gravity anomalies and surface cracks nobody has been able to explain any other way. None of these worlds sit anywhere near what most people picture when they imagine a place life could exist. And yet, one after another, they keep turning out to be more chemically active, more connected, and more alive-looking in their processes than anyone ever expected from a frozen moon that far from the sun. Europa was supposed to be a sealed, silent ball of ice. Its ocean found a way to leave a signature on the surface, in a spot a telescope 400 million miles away could actually read. And now we have a mission designed to follow that signature in person. If that is what one moon was hiding, it is worth wondering what the rest of them are still keeping quiet about. Europa Clipper gets to Jupiter in April 2030. Every step of that journey is on the books already. If you want to be here when it actually arrives, when the question Webb just opened gets its next real answer, subscribe. This is the channel that covers space discovery straight from the published research. No exaggeration required. And the part of the solar system Webb is quietly rewriting right now, it's about to get very crowded.